Good morning, my YouTube viewers. It is Crystal here, and I want to do another video for you. This is the second video I've done for you as a code review, and basically I did it once before, and the video stopped, so I'm going to try to do it a second time. And basically, what I had done previously is I was going onto Google and looking at Wikipedia to explain to you these different concepts, but I'm not going to be able to do it in this video because I think that may be one of the things that caused my video to crash. So I'm going to be going over all of this information from memory. Okay, so you're going to get the benefit of my memory, which is in its 7th decade. Okay, so basically, what we're going to be doing is we're going to be talking about the central limit theorem. And the central limit theorem states that if you have a population and you sample the population enough, the mean of the sample is going to be a normal distribution. And what I had wanted to do is I wanted to go onto Wikipedia and Google and explain that to you, but unfortunately I can't because the system might crash if I do. So this is it. I've made normal distribution here using population normal equals np.random.normal. Log is your mean, scale is your standard deviation, and size is the number of samples, or the number of how big it's going to be, 500. And then I created a histogram of that, and you can see the histogram. But before I created this normal distribution, I had to import my libraries. And so my libraries are going to be NumPy as NP, which performs numerical computations, Pandas as PD, which performs data processing and creates series and data frames, matplotlib.pyplot as PLT, which is a graphics library, and Seaborn, which is also a graphics library written on top of Matplotlib. So you can see I've created a histogram of this normal distribution, and I just created another histogram that's got a line representing the mean and the median, so you can see where the mean and the median is. So now we're going to talk about the central limit theorem, which, as I previously stated, if you sample your population enough times, then eventually the mean of the population is going to resemble a normal distribution. And so what I've done is I created a little bit of code here. It says population list equals list population normal, because that's the population we just created. Samples mean is a blank array, and then we're going to check 100 samples. So for I in range 100, sample of population equals sample population list 10, which means you're going to take 10 elements for that sample. Mean of sample equals PD series, sample of population mean. Samples mean dot append mean of sample. So every iteration you're going to append the mean of sample. Samples mean equals PD series samples mean. And then we print the length of sample, which is 100. We print the mean of the samples, which is neg 1.58. And then we print the standard deviation, which is 5.9. And then what we do is we're going to create a histogram of samples mean, and you can see it sort of looks like a normal distribution or a Gaussian distribution. So now what we're going to do is we're going to use the code, again, the exact same code, but we're going to sample it 1,000 times. So your mean is neg 1.4 and your standard deviation is 6.12. And you can see that we look on the, create a histogram, and you can see that the histogram, the samples, are more closely resembling a normal distribution. So now what we get is we're going to sample it 1,000 times. So we have a mean of neg 1.3 and a standard deviation of 6. And so you can see that the distribution made is closely resembles a normal distribution. So now what we're going to do is we're going to check uniform distribution, and that's where all of the samples, excuse me, all of the elements have the same probability. And so uniform distribution, population uniform equals np.random.uniform, low equals 5, high equals 20, size equals 500. So you can see the histogram that was created, and I made a new histogram where you can see the mean and the median in the chart. Now we're going to use the central limit theorem. It's exactly the same code, it's just population list equals list population uniform, and all the code is the same. We're going to sample it 100 times, so you have a mean of 12.33 and a standard deviation of 1.4. So you can see that the histogram that has been made. So now we're going to sample it 1,000 times. So when we sample it 1,000 times, we have a mean of, let's run it again, because it didn't show our mean. I don't know what happened there, but it didn't show the mean. So the mean is 12.29 and the standard deviation is 1.3. We see the histogram that has been created, and you can see it's looking pretty close to a normal distribution. And now we're going to sample it 1,000 times. And when we sample it 1,000 or 10,000 times, we've got a mean of 12.33 and a standard deviation of 1.33. And you can look at the histogram that has been created, and it looks very much like a normal distribution. Now we're going to do the exponential distribution. So population exp equals np.random exponential, scale equals 20, size equals 500. And so your scale is your standard deviation. And then I made another histogram for you so you can see where the mean and the median falls in the chart. And now we're going to look at the central limit theorem. The only difference is the population list is population exp, and everything else is the same. So when we had 100 samples, our mean was 19.25 and our standard deviation was 5.47. So we look at a histogram, 100 samples, and you can see what it looks like with 100 samples. Now we're going to sample it 10,000 or 1,000 times. So the mean of the sample is 18.73 and the standard deviation is 5.3. So the histogram created, you can see that that's looking a little bit better. It's looking closer to a normal distribution. So now what we're going to do is we're going to sample it 10,000 times. And when we sampled it 10,000 times, the mean was 18 and the standard deviation was 5.44. So we created a histogram of that. And you can see that the histogram looks pretty close to a normal distribution, except for the fact that it is still a bit right skewed. And what I had originally done was I had sampled it 100,000 times, and then I even sampled it 1,000,000 times, and it was looking better and better. Then it was looking more and more like a normal distribution, but it just took so much time to sample it 100,000 times and then 1,000,000 times that I decided not to include it, because I thought, well, this is going to take a lot of time for me to run it up, and I don't want to do that. Now we check our beta distribution. So you can see the beta distribution is population beta equals np.random, and then beta is 0.5, 0.5, and size equals 500. And so you can see what a beta distribution looks like. So I created a histogram, and you can see where the mean and the median fit in this histogram. So now we're going to check the central limit theorem. The only thing that we changed here is population beta. All of the other code is exactly the same. So when we sample it 100 times, the mean is 0.45 and the standard deviation is 0.114. And so when we sample it, you can see what the distribution looks like with 100 samples. Now we're going to sample it 1,000 times. So your mean is 0.48 and your standard deviation is 0.115. And you can see that the distribution is looking a little bit more like a normal distribution. And so now we're going to sample it 10,000 times. And when you sample it 10,000 times, your mean is 0.48 and your standard deviation is 0.113. And you can see when you have 10,000 samples, you can see that you have a normal distribution. So what we've done is we've used all these types of distribution. We've used a normal distribution. We've used, let's see what we've used. We've used a normal distribution. Excuse me, I don't enjoy good health. We used a uniform distribution. We used an exponential distribution. And we used a beta distribution. And all of those distributions, when you took samples, if you took enough samples, they all formed a normal distribution. And so that's the central limit theorem. And basically, we have proved the central limit theorem using Python and using, well, definitely, I believe it was 4. It was normal. It was normal, it was uniform, exponential, and beta. Normal, uniform, exponential, and beta. And please forgive my 61-year-old memory, but that's what it is. We proved it. We proved the central limit theorem, which is what I set out to do. And I'm also going to make a blog post on it as well. So I'm going to go ahead and conclude this code review, conclude the fact that we proved the central limit theorem. If you like my video, please like, subscribe, and share. I would like to thank all of my subscribers for supporting my channel. And thank you very much for watching my code review. I look forward to making more code reviews for you in the future.